Okay, so let's dive into some hypothesis testing for mean problems. USA Today reported recently that executives spend 1 hour reading and sending email. So a statistician doubted that and conducted a survey of his own. He found 162 executives yielded a mean of 63.7 with a standard deviation of 18.94 minutes. So we want to test the alternate hypothesis that the mean is not 1 hour and the level of significance is 5%. So notice we're trying to say, or we're trying to claim that the mean is not 1 hour. So basically our alternate hypothesis is not equal to 1 hour. Now since the data is in minutes, we want to do not equal to 60 minutes. Okay, so that means the null is going to be equal to 60 minutes. Remember, we always have the same numbers in the null and the alternate. The equal sign is always in the null. And we have 5% level of significance. So we either have evidence for the claim that it's different from 60 minutes, or we didn't find enough evidence for the claim, and we just go with the null. Okay, so just a quick note, the claim is always in the alternate hypothesis, so if you reject the null, then you do have evidence for the claim. Okay, so let's look at this in Megastat. And you'll see in Megastat the p-value is actually 0.0139, which is less than alpha. So we will find that we can reject the null, but let's take a look. So I'm going to use the summary input because I don't have the raw data, I just have the mean, standard deviation, and sample size. Put the label first, and then 63.7, 18.94 in minutes, and the sample size of 162. And select that input range. Your hypothesized mean that you're trying to disprove is the 60 minutes. Remember, it said 1 hour, but our data was in minutes, so we changed that to 60 minutes. It's not saying it's gone up or down. We just want to test that it's different from. So we'll choose the not equal to for the alternate hypothesis. Again, always use t-test for these problems. And since my level of significance is 5%, I just leave that on the default 95% confidence. Okay, so here's the output once you hit OK or submit. And the p-value is 0.0139. So here's the decision. Since the p-value, 0.0139, is less than alpha, 0.05, we can reject the null and support the claim that the average time is different from 60 minutes. So basically we found enough evidence to prove the different from 60 minutes. Okay, that 63 point whatever was enough. It was statistically significant enough to prove the claim instead of the null. We reject the null. Okay, so notice that if we wanted to be more confident, like 99% confident, then our alpha would change to 0.01. And notice 0.0139 p-value is not less than 0.01. So here's a case where if we're changing the confidence level, we're changing the decision. So there's some leeway there. You know, if you want a decision to be a certain way, as long as you're choosing 90, 95, 99%, you're going to be okay choosing those common levels of confidence, common levels of significance, or common, yeah. So, you know, in this case, maybe we would want to go with 95% confidence if we want to have support for the claim. Okay, yeah, and like I said, so 0.0139, the p-value, is not less than 0.01. So if we need to be 99% confident, we don't have enough evidence for the claim. If we can reduce it down to 95% confidence, then we can support the claim that it's different from 60 minutes. Okay, and this problem shows that the conclusion can vary based on the level of significance or confidence level. If you want to show evidence against the null and you're okay with 95% confidence, that might be the way to go, like I said. Okay, at the 95% confidence level, we can conclude that there is evidence against the average being 60 minutes. Okay, here's another problem. A courier claims that it takes less than 6 hours for delivery. So basically, we've got the 6 for our hypotheses, and the courier is claiming less than 6. So in our alternate hypothesis, we have a less than problem. We have a less than in the alternate, which means it's a less than problem. The null will always have the equal sign, or in this case, and I could also put greater than or equal to. So here's a case where we actually have the data, the raw data to enter. Okay, so is there evidence at the 5% level of significance to support the courier's claim? Either yes, we do have evidence for the courier's claim that it's less than 6 hours, or no, we didn't find enough evidence to support the less than 6, and we basically are going with the null. Okay, so if I'm choosing A, yes here, that means I found evidence for the alternate hypothesis. If I'm choosing no, then I didn't find evidence for the alternate, so I'm going with the null. Okay, so here's a case where we're going to do the data input instead of the summary input because we have the raw data, and these are the courier times in hours. Okay. Hypothesized mean is going to be 6 hours, and it's a less than problem. Remember, you're always, the alternate hypothesis is what's going to determine that less than, greater than, or not equal to. Again, I have 5% level of significance, which means 95% confidence. And I have a pretty high p-value of 0.2538, or at least compared to the p-values we've seen so far. And notice it's also not highlighted, so it's basically highlighting it when it's less than alpha. But in this case, 0.2538 is not less than alpha. So here's a case where I'm not rejecting the null. And in that case, I'm going with the null. So I don't have support for the claim. Okay, the 0.2 p-value is not less than 0.05, which is alpha, my level of significance. So I can't reject the null. There is no evidence that the time is less than 6 hours. The courier does not have a case. Okay? If I'm not rejecting the null, I'm going with the null, and I don't have evidence for the alternate. Okay, let's look at another example. The ideal temperature for brewing coffee is 92 degrees Celsius. On average, notice the term average, so this is a mean problem. Does Lucille's brew their chicory coffee at the ideal temperature? State the null and alternate hypotheses. Okay, so first of all, it's in Celsius, so we can eliminate B. We also are trying to see if it's 92 degrees or not, right? So I'm not trying to prove that it's less than 92 or that it's greater than 92. I just want to see if I'm at the ideal or not. So here's a case where we're basically not wanting to reject the null. In a lot of cases in the past, we sort of wanted support for the claim or the alternate hypothesis, so we wanted to reject the null. But here's a case where the null is basically that it's equal to the ideal temperature. So here's a case where we don't want to reject the null. Okay, and so the answer here would be C. We just want to see, we're trying to claim that it's different from 92, and the null is that it's equal to 92. Remember, the null will always have the equal sign. Okay, so our next step is to take a sample so that we can enter the data. We have a sample of 35, showed that the average and standard deviation were 90.5 degrees Celsius, 14.3 standard deviation. Find the p-value for the average of this sample. Recall that the ideal temperature is 92 degrees Celsius. Okay, so let's take a look. Insert the summary data first, again in the format label, mean, standard deviation, sample size. Okay, we're still doing mean versus hypothesized value problems. Okay, so I enter the summary input this time. So change that from data input to summary input. And then the hypothesized mean is that 92 degrees Celsius. And I just want to know if it's different from 92. So I'm just choosing the not equal to for the alternate hypothesis. Keeping the level of significance at 5%. The p-value is 0.5390. Okay, notice also that it's not highlighted. So if it's not highlighted, it's not a significant p-value. So basically you don't have enough evidence. You can't reject the null. Okay, 0.539 is not less than 0.05, so I can't reject the null. In this case, that's a good thing. Like I said, the null was that it's equal to 92 degrees Celsius, which is the ideal temperature. There is no evidence that her coffee is too hot or too cold. And she doesn't have to change her business process. Okay, so if the level of significance was 0.1, the correct conclusion based on the p-value is there is strong evidence to conclude that Lucille's is not brewing their coffee at the ideal temperature. A larger sample size is required. We do not have strong evidence to conclude that the temperature is different from ideal, and standard deviation is too large to tell. Basically, we're getting the same conclusion we had before. The p-value is really high. It's not less than 0.1, so I can't reject the null. So we do not have strong evidence to conclude that the temperature is different from ideal. So C would be the answer there. Okay, now next we're going to do hypothesis testing for proportion.